So now we've seen some examples of groups and we've thought about addition and multiplication. This next definition is going to combine the two ideas because many of our sets have both properties, have both binary operations. So a ring is a set with two binary operations, something like addition and something like multiplication. And with those two binary operations, we have a bunch of properties. So we're going to work through these and talk about them. So the first one, that's our addition is associative property. The second one, there's a zero. That's an additive identity. Okay, so a ring has an associative additive property, an additive identity. For every element in the ring, there's a minus a. That's an additive inverse property. And notice that properties 1 through 3 here, that says, if we ignore the multiplication entirely, this says R is a group under addition. Those are our group properties. Property 4 is an additional stipulation on addition. Sorry, that's a lot of adds. An additional stipulation on addition that says addition is commutative. So this says that A plus B is the same as B plus A, which is something we did not demand before, although it was always true in the examples we had. All right, so property 5. This is now another associative property, but this time it's for that multiplication. So the multiplication is associative now also. Number 6 here says there's a 1, where A times 1 is 1 times A, which is A. That's talking about a multiplicative identity. Okay, and then property 7 is combining the two. So this is a multiplication over addition. This is a distributive property. All right, so when we have all of those properties, we call our set a ring, and we've seen a lot of examples of rings. I think we'll set up a little chart of examples for ourselves, and I'm gonna kind of list a set to the side. So let's start with maybe the integers. And then the properties, I'll just number as 1, 2, 3, 4, 5, 6, 7. Okay, so we're just going to talk through these a piece at a time. So addition, for sure we had under the integers that addition was associative, so that was great. There's 0 is an integer. Every integer, like 17, has an inverse, like negative 17, an additive inverse. Definitely A plus B is B plus A in the integers. Multiplication is associative in the integers. 1 is an integer, so the multiplicative identity, and we know the distributive property holds. In fact, this is all working out really nicely because the integers sit inside bigger sets that we know all of these properties for. So the rational numbers are the same. All of these hold on the rational numbers. And in fact, they all hold on the real numbers. Addition is associative and commutative, and we have an identity in the reals, and the same goes for all the multiplication. So all of those sets behave really nicely. All right, and then we can extend this a little bit further. So let's talk about polynomials. So remember, this Rx was our set of all polynomials with real coefficients. So we can call that polynomials over R. The coefficients are real numbers. All right, so property 1, that was addition is associative. We know how to add polynomials, and it was an associative addition. We had a 0 polynomial. We talked about that. We have additive inverses for our polynomials. And addition of polynomials is commutative for sure. All right, so then property 5 is talking about multiplication. I know how to multiply polynomials, and that multiplication is associative. I have a multiplicative identity in polynomials. That's the polynomial 1. And I can distribute. When I'm multiplying and adding polynomials, I can distribute a polynomial over a sum. That's our like foiling it out method, is applying that distributive property. All right, so those are some of the sets that we know. These are all rings. So these are examples of a whole bunch of sets that we know that are rings. All right, so in the next video, we're going to look at a couple of more examples that are also rings, one that we haven't seen before, and one, the set of matrices that we know a lot about under addition, but we also now want to talk about them under multiplication.